So next we have OR gate. So this is the symbol of OR gate. Again we have two input OR gate. A and B are the inputs and Y is the output. This is the logic circuit with the help of the diode. Here you can see we have used two diodes only for two inputs A and B, and there is no VCC supply here. And here we have a resistor and we have connected further it to the ground. And from the N side of both the diodes we have taken our output, which is Y. So similar way this circuit will also work. When we apply a high logic here or one input here, this is the P side of the diode and these are the N sides of the diode. So when we apply 1 here, the other side is already connected to ground. Okay, so these diodes will become forward biased. So you already know a forward biased diode conducts and allow current to pass through it. So current will start flowing in this direction and will move towards this direction, and as there is a resistor connected here, so current will not go to the ground. It will go towards a low resistance path. So as in this path there is no resistance, the current will move towards the output and we will get a 1 output here. So when both the inputs are 1 1, we are getting a 1 output. Here in the truth table also you can see when both the inputs are 1 1, we are getting a 1 output. Now A is equal to 0 and B is equal to 1. Now this diode will not be forward biased, it will not conduct. Only this diode will conduct, as 1 is given to the P side and ground is connected to the N side. Only this diode will conduct now, and all the current will flow from this diode to again towards the output side, not towards the ground. So we will get a 1 output. So if any of the input is 0, we are still getting a 1 output. What happens if both the inputs are 0? If both the inputs are 0, here also we have a low logic, here also we have a low logic. So there is no potential difference. So no current will flow. Current only flows from higher potential to lower potential. So as no current flows, we will get a 0 output here. So you can see in the truth table, when both the inputs are 0, we are having a 0 output only. Similarly, as in the AND case, we can also make the diagram with the help of transistor also. Here T1 and T2 both are connected in parallel, and to their base we have applied A and B inputs. Their collectors are connected to the plus 5 volt power supply, and here we have third transistor T3. Its base is taken from the collector of both the two transistors. So its collector is connected to the base of the transistor T3, and from the collector of the T3 we are getting final output Y. So what will happen? Whenever we will give 1 to the input, the transistor will get into saturation. So as we are applying 1 1 to both the inputs, both the transistor T1 and T2 will enter into saturation, and as they both are conducting, the current will start flowing through them. So current will start flowing through them, and this current will move towards the ground terminal. We will not get any voltage drop, or the voltage drop here will be very minimum. We will not get sufficient current to turn on the transistor T3. So T3 will remain off. As we are getting no current at the base of the transistor T3, it will remain off, and as it is off, it will not allow current to pass towards the ground through it. All the current will pass towards the output. So we will get a 1 here. So when we are giving 1 1 inputs, we are getting 1 at the output, as already shown in the truth table. For 1 1 we have a 1 output. And when both the inputs are 0 0, both transistor T2 and T1 will remain off. They will be in cutoff region or cutoff state, and they will not allow the current to pass towards the ground through them. We will have a voltage drop here and sufficient current to make the transistor T3 on. Now transistor will be on, and it will allow the current to pass towards the ground through it, and we will not get any current at the output. So we will have a 0 output here. So when both the inputs were 0, 0, we are getting a 0 output as already shown in the truth table. And if any of the input is 0 and another one is 1, similarly we will have that transistor will conduct and allow the current to pass through the ground, and we will not get any signal at the base of the transistor T3, and T3 will remain off, and we will get output 1 at the Y terminal as already shown in the truth table. So in this manner OR gate circuit will work.